Hey guys, and welcome back to another lesson in Algebra 1. Today's lesson is over Unit 2, Lesson 4, and we're going to be looking at inequalities some more, and it's going to be specifically what we call applications of inequalities, which is word problems. So you're going to use keywords to help write your inequalities from real world situations. And then once you write those, you can solve those based on these real world situations. I am going to encourage you to annotate your problems, highlight and underline keywords. And I have a list here of words that may help you decide what kind of inequality sign you even use when given these word problems. So, I'll refer back to these as we go through and read them. Like this list would mean a greater than, this list would mean a less than, and then, these lists would mean these inequalities here. So let's go scroll down and let's start breaking this down. All right. So, the first thing that we're going to do when we're doing this is we're going to use a let statement to define your variable. Okay, so part of the problem with any sort of word problem is deciding what on earth it's even asking, and then once you decide what it's asking and you put it in a variable format, reminding yourself what it is that you're even solving once you solve the equation. That's what defining your variable is about. So, a let statement would look something like this, like say let x equal number of days or something like that. We're defining it so that when we go and solve it, we can remember what does X mean when we get the answer. Um, and then the second step is if comparing two things, we are going to write the inequality for each half. Now, the first couple of problems I gave you in these notes, we're not going to be comparing two different things. We're just going to have one thing. But most of your problems are going to be comparing two things. So let me give you an example of what I mean. We might have, a situation, related to say, Noah's savings, and you would write an inequality for that, and compare it to Natalie's savings. Okay. So we would end up writing an inequality half, an expression for how Noah is saving his money. And then we would write an expression for how Natalie's saving her money. And then we would compare those two with our sign. And I know that may be gibberish, but we'll come back to it with the examples. All right, let's look at number 3. We're going to use keywords to decide the inequality symbol. To use. And so, that's all of these guys up here. So there's all these keywords that can come up in these word problems, and the symbol that they mean are listed up here. So I gave you lots of examples. And then the last step when solving these inequality word problems is going to be write your answer with units. And the question is, does it make sense? So we want to double check and look over our problem and see, did we solve and find the answer that we meant to solve for? Okay. So when we look at example number 1, we're going to start putting this in practice. So let's first read over this and so I'm just going to read through it in one pass, and then I'm going to go back and start figuring out what the components are that are important. So it says Lena has $417 in her savings account. She must keep at least $75. And I can give you a hint here that at least is one of those key phrases that refer to an inequality symbol. So she must keep at least $75 in the account to avoid a penalty. Her music subscription costs $18 per month. Write and solve an inequality to determine how many months Lena can pay for the subscription before her balance drops below the minimum. Okay? So let's start breaking this down. What on earth does all of this mean? Well, we can see here that she is starting with some amount. She's starting with $417. She must keep at least 75 in there to avoid a penalty. And then her subscription costs $18 per month. Okay. And what we want to do when we're solving this inequality is we want to determine how many months she can pay before her balance drops below the minimum. Okay, so when we see that this is my question, how many months? My let statement, my first step over here, I said use a let statement. I'm going to write let x equal number of months. Okay, that's what we're looking for. We want to see how many months she can do this. Now, I'm going to create a plan. We need a plan for how we're going to do this. So I'm just going to break this down into words to try to help figure out what my plan is. So if we have a starting amount, so this is going to be my starting money. She is going to spend, so it costs 18 per month. She is going to spend some amount, and whatever is left over must be at least 75. Okay, well, what the heck does at least 75 mean? Let's go look up here and let's see what at least is. So I'm scrolling through this. I don't see at least. I don't see at least in this one. Oh, look, at least. Okay, so we're going to do this greater than and equal. Okay. All right, so how does this work? I've got my greater than and equal. So whatever starting amount that she has minus what she spends can be equal to 75, or it has to be greater than that. And that's why that greater than sign is pointing to the left, because this side over here has to be $75 or greater. Okay, so what is she starting with? She's starting with $417. Okay. What is she spending? She is spending, and this is going to be a minus because it's cost, $18 per month. So it's $18 per month. So 18 times X, and X is my number of months. That's going to be greater than or equal to her leftover. The leftover amount has to be the at least 75. Okay. So I put this greater than and equal, 75, it's got to be that or bigger. Now we can solve it. Okay, we have set this up. We came up with a plan. We're going to set this up. So my X is on my left-hand side, and there's no X's over here on the right. I'm just going to move all my numbers over here to the right. So I'm going to subtract 417. Okay, so that cancels. I get negative 18X is greater than or equal to 75 minus 417 is going to give me negative 342. Okay, I want to notice something here, just a little warning symbol in my head. I've got a negative there with my coefficient to that X, which means when I go divide by this, I've got to flip my inequality sign. So I'm going to divide by negative 18. Okay. And that is going to give me X is less than or equal to negative 342 divided by negative 18 is 19. Well, what did we just solve for? We solved for 19 what? 19, mules? Like what did we solve here? 19 months, okay? We wanted to know how many months she can pay for. This is one reason why we write the let statement, because by the time you've done all this, your brain gets confused and overwhelmed, and that's why we write it down. Okay, so 19 months. Well, what does this mean? Okay, we solved this, but what on earth does it mean? So if we are subtracting $18 per month, she can pay, Lena can pay up to 19 months of her subscription. Oops, I misspelled that. Let's see, let's go fix that. Subscription. I'm just going to put sub. We'll just put sub there. Of her subscription before going below 75. Okay. That's what that means. Let me see. Subscription. Hopefully I still spelled that right. Nope, I still script. Okay, so she can spend up to, or she can pay for 19 months, up to 19 months. So she could pay for 3 months, 4 months, 0 months, or 19. But once she hits that 19, she can't pay for any more without having to figure out how to add more money to her account. Okay, since she has to keep a minimum 75. Okay, let's look at example 2, and I'm going to read over it, and then I'm going to go through and try to figure out what does everything mean here. So it says Franklin is selling handmade candles at a market. His table fee and supplies cost $260. So this means to be at the market cost him $260 before he's made any money at all. Okay, that's what that's telling us. He has already saved $35 from the previous sell. And if he sells each candle for 15, how many candles must he sell to make at least enough money to cover his costs? Alrighty, let's go through and let's read that again. So we got Franklin is selling handmade candles. His table fees and supplies cost $260. He has 35 saved from another sale. If he sells each candle for 15, so each candle is 15, how many candles must he sell to make at least enough money to cover his costs? Okay, so the question that we see here, we see this. How many candles must he sell? So when I write my let statement, in this case, X is going to equal number of candles sold. Okay, that's what that equals. Okay, well, how do we know how many candles he needs to sell? So let's think about what our plan is here. So he's going to make some amount of money. So let's see, he's going to, money. Well, let me go ahead and erase this. We're going to say he's going to sell some amount of candles. So he's going to sell candles. And he has, already saved some amount of money. And then his expenses. Remember, we want to make more than our expenses. If it's a business, he wants to make more than his expenses, right? So what inequality sign are we going to put in there Well, the inequality sign is this, at least. Well, what does at least mean? Let's go look up here and let's see. Okay, at least is right here. So we've got this symbol here, the greater than or equals. And that makes sense because the amount of money that he makes from candles plus the amount that he has saved, we want it to be, I mean, it could be equal to expenses, but we want it to be greater, right? Like that's the way businesses work. Okay, well, how is he going to make his money? He's going to make his money by selling candles. And so each candle costs $15. So when he sells his candles, he's selling them for $15 each. So that 15 touching the X, that means 15 times X, or 15 times the number of candles. Plus, he has saved $35 from his previous things. We want that to be greater than or equal to his expenses. How much his expenses? Well, it's going to cost $260 just to be there. So now that we have an inequality set up, we took those words and we converted it to an inequality. Let's start organizing this. So I'm going to move my 35 over. Bring down my 15x is greater than or equal to 260 minus 35 is going to give me 225. Okay, so I'm going to divide by my 15. Okay, x is greater than or equal to 225 divided by 15 gives me 15. Well, what did we just calculate? X is greater than or equal to 15. 15 what? Again, is it like mules, dollars, schools? What? I mean, 15 what? Well, we look up here. It's the number of candles. Okay. So 15 candles. All right, we can draw a box around that. Okay, if we wrote this in words, this is what we would get. Franklin must sell, and I'm going to take this phrase from up here, at least 15 candles to cover his expenses. Okay. And businesses have to think about this sort of thing all the time. Like it's not accidental. When they're making money, they know their homework. They know what they have to sell. They know what everything costs, and they know what they need to do in order to cover their expenses. And then they also, of course, want to make a profit. So make sure that your sentence makes sense with what we've solved and that it answers the problem. So it says, how many candles must he sell to make at least enough money to cover his cost? Okay, well, we figured that out. 15 candles will pay for it all. Okay, we're going to read this problem here, and this is where we're going to start comparing two quantities. So we have two smoothie shops, and they charge different prices. Fresh Blend charges $1.25 plus 45 cents an ounce, and Smoothie Spot charges $2 plus 30 cents an ounce. Write and solve an inequality to determine after how many ounces Fresh Blend becomes more expensive than Smoothie Spot. All right, we're going to define these things. We've got to know what everything means here. Okay, so first thing I'm going to do is I'm going to define, let x equal, well, what is it that we're trying to find? And it says after how many ounces. So my x is going to be number of ounces. All right. Well, what are we comparing? Let's come up with a plan. And then once we come up with a plan, we can, figure out the other components. Okay, so it says write and solve an inequality to determine after how many ounces fresh blend becomes more expensive than smoothie spot. Okay, so my plan is that fresh blend, and I'm just going to call this fresh rather than writing it all out. Fresh blend becomes more expensive than smoothie spot. And so more expensive means it's going to be this kind of sign, right? It's greater than. When is fresh greater than smoothie? And then you're like, well, what do we even put in for fresh and smoothie? Let's go define that a little bit more. So, fresh, we're going to get its part of the inequality from this. It charges $1.25 plus 45 per ounce. Okay. So it charges 125 plus 45 cents per ounce, and we defined our ounces as X. Smoothie spot is doing $2 plus 30 cents per ounce. So $2 plus 30 cents per ounce. Well, now that we know what fresh, blend, and smoothie spot are, we can plug it into our plan here. So I see on the left side, I have fresh blend. So I'm going to take this part and I'm going to write that in for my inequality. I have 1.25 plus 0.45x. At some point, that will be the more expensive option versus smoothie, which is $2 plus 30 cents. Okay, now we can compare those. So I am going to simply rearrange everything just like how we've done every inequality up until now. I'm going to move my x's to my left and the numbers to the right. So I'm going to go ahead and subtract 0.3x. And I'm going to move it over here. And so we get $1.25 plus 0.45x minus 0.3 is going to give me 0.15x greater than 2. And so now I can move this 125 over. And we got 0.15x is greater than 2 minus 125 is going to give me 0.75. And now I can divide by 15. 0.15 divide by 0.15, and that cancels. And then we get x is greater than 5. 5 what? Look back up here. What did we calculate, or what did we say it was? It's the number of ounces. How many ounces fresh blend becomes more expensive than smoothie spot? Okay, so this is going to be ounces. Alrighty, if we wrote this in a sentence to further explain what this means, is that fresh blend is the more expensive option at more than 5 ounces. Okay, and the abbreviation for ounces is OZ. So at 5.000001 ounces, it is your cheaper option. And if you went and got a bigger one, 10 ounces, it's your cheaper option. 15 is your cheaper option. But if you wanted a really tiny one, like say at 3 ounces, Smoothie Spot is your best option. Okay, our last example is we're going to compare Natalie and Noah and their candy. So it says Natalie starts with 110 pieces of candy. Noah starts with 94 pieces. Natalie eats 4 pieces a day. Noah eats 2 pieces a day. Write and solve an inequality to determine after how many days Noah will have more candy remaining than Natalie. Because right now, Natalie has 110 and Noah has 94. So right now, Natalie has more candy, but she's eating it faster. So at some point in time, Noah will have more candy because Natalie will be eating her candy faster than Noah. So let's figure out what on earth we need to write down about this. So it says, write and solve an inequality to determine after how many days. This is our part right here where we know what our x is going to be. Okay, so based on this, how many days, my let statement, oops, x equal number of days. Okay. Well, what's our plan? Let's figure out what's going on. So it said here, determine after how many days Noah will have more candy remaining than Natalie. Okay. So at some point in time, Noah and Natalie, we could compare their amount of candy, and at some point in time, Noah will have more of it. Okay, more candy means, the inequality is pointing towards him. Well, what does it mean? Like, we got to come up with some sort of way of saying, how much candy Noah has and how much candy Natalie has. So let's kind of define this over here. So we're going to do Noah. Let's go read up here and see what he has. So Noah starts with 94 pieces, and then Noah eats 2 pieces a day. Okay. So if he starts with 94 pieces and he's eating them, the eating is like subtracting, right? He's eating those and he's eating 2 per day. And we just said days was our x. So 2x. Natalie, let's go see what she's doing. Okay. So, wait, no, I want to do this. Okay, so Natalie starts with 110 pieces and she eats 4 pieces a day. So we can write that mathematically. She starts with 110, but she eats 4 a day. 4 times x, and x being number of days. Okay, now that we know our 2 halves of our inequality, we can plug it in here to our plan. So I'm going to write Noah on my left, and Noah is 94 minus 2x. And that's greater than Natalie, and this is my plan for Natalie, 110 pieces of candy minus 4 per day. Okay, so now it's just an inequality that we can rearrange. So I'm going to move my x's to my left. So we got 94 plus 2x is greater than 110. And I'm going to move my numbers to the right. So I'm going to subtract 94. And we get 2x is greater than 110 minus 94 is going to give me 16. And so I am going to divide both sides by 2. And so I end up with x is greater than 8. And what is our 8? It's going to be 8 days. Okay. And that's why we define our x, so that we know what on earth that number is that we just calculated. So we found 8 days. Well, what does this mean in a sentence? So what it means is after 8 days, Noah will have more remaining candy than Natalie. So you know, for the first 8 days, Natalie will have more. But then on day 9, Noah will have more because Natalie's eating her candy faster. I hope that helps, guys. Until next time, bye.